It's another math day here with teacher Jenny. Join me for another topic, and this time we're going to talk about linear and angular measure. Linear measures refers to the measurement of the arc length, while angular measure refers to the measurement of an angle subtended by the arc. Let us find our linear measure of a 210 degrees central angle in a circle with the radius of 10 cm. So knowing that the relationship between the linear measure and the angle measure is, we've got an S equal to theta r, wherein S stands for the arc length, and theta there stands for the angle measure, and r stands for the radius. So going back to the given information, we are now given with an angle measure, which is 210 degrees. Now, since this is in degree form, we have to take note that using this equation, our angle there, or the theta there, must be in radian form. Otherwise, if that is in degree form, we have to convert that one into radian form. So converting this one into radian form, we multiply that one with a pi rad over 180 degrees. So again, the conversion here is pi rad is equivalent to 180 degrees. So it's right for us to multiply 210 degrees by pi over 180 degrees. Canceling the unit here, which is degree. We may now simplify this one, knowing that the 210 is understood with 1 here as the denominator. So in simplifying or multiplying fraction, we may cancel a common factor on the numerator and the denominator before we multiply that one, so that it's a lot easier for us to multiply. So for this one, we've got 210 and 180. Greatest common factor for that one is 30. So we divide 210 by 30. This is equivalent to a 7. And 180 divided by 30. This is a 6. So simplifying this one, so we have now on the numerator, we have 7 multiplied with the other numerator, which is the pi. So we have 7 pi over 1 times 6. That will be a 6. So since it is already now in radian form, so we may now use that one on the equation. Then we've got the other given, which is the radius of the circle, which is 10 cm. So utilizing the equation above, we have S equal to theta r. Plugging in, we've got S equal to theta is 7 pi over 6 multiplied with the radius, which is 10 cm. And again, our 10 here is a numerator. This is understood with 1 as a denominator. Numerator, denominator, checking. This is with common factor, which is 2. So we divide the denominator here, 6 by 2. 6 divided by 2, that's 3. 10 numerator here, we divide that 1 by 2. This is a 5. So simplifying that one, our S here is 7 pi times 5 is a 35 pi. And 3 times 1 is a 3. We've got a unit, which is a cm. And that is what we have as the arc length, or the linear measure. So let us now move to finding the linear measure of a 30 rad central angle in a circle with a radius of 3 cm. Our angular measure here is 30 rad. So all we have to do again is to make use of our S equal to the theta times r, in which we have the given information on the problem as our theta is now in 30 rad, wherein that's already in radian form, so we do not bother converting that one anymore. And then our r here is at 3 cm. So we are now off in solving our arc length, or the linear measure, which is S equal to theta r. Plugging in the information, we've got 30 rad, or we do not need to write the rad unit anymore, because in angular measure, without the rad unit written, that is already understood that that is in terms of a rad. Because there are only two angular measures or unit of angular measure, which is a degree or a radian. So if you have, if you cannot see a degree unit in there, so that is understood that that is a rod. So we have there 30 times, our radius is 3 cm. So 30 times 3, that will be equivalent to a 90 cm. And that will be our arc length. So our arc length here is a 90 cm. We are to find the linear measure of a 3 pi over 2 central angle in a circle with radius of 2 cm. So identifying our given before we proceed with a computation, our given information are the following. We have the 3 pi over 2 central angle, so that is our theta, that's equal to 3 pi over 2. This is in terms of a radian already, so we don't bother converting the one. And the radius is equal to 2 cm. So using now our linear and angular measure relationship, we have our S is equal to theta r, wherein our theta is 3 pi over 2 times our r, which is 2 cm. So 2 is numerator. This is understood with 1 as a denominator. Canceling common out on denominator and numerator, we have 2, which is common. So we cancel that 1. This becomes 1, while this 1 becomes 1 as well. So simplifying, our S here is equal to 3 pi times 1 is a 3 pi. And then 1 times 1 is a 1. So we copy the unit, which is a cm. Our arc length here, or the linear measure, is 3 pi cm. Going over to finding the arc length along a circle of radius 5 units, subtended by an angle of 110 degrees. Again, going to the given information, we have there our angle, which is 110 degrees. And we've got the radius as well as 5 units. So our S is unknown. So all we have to do is to use our linear and angular measure, which is S equal to theta r. Plugging in, we've got our theta as 110. But take note, our theta is not yet the final one because we need to convert this one into radians. So we have 110 degrees. We multiply that one with a pi over 180 degrees. Canceling the unit in there. And canceling also the common out, which is a 10. So 110 divided by 10, that is an 11. 110 divided by 180 divided by a 10, that will be an 18. So our angle here is 11 pi over 18. So utilizing that one, we've got 11 pi over 18. We multiply that one with our radius, which is 5 units. So since we cannot cancel something out of the denominator and so with the numerator, and this one is understood with 1 as the denominator, so all we have to do is to just simply multiply our numerator to numerator. 11 pi times 5, that will be 55. And then we've got a pi. And we have 18 times 1, that is an 18. And then the unit here is still in terms of units. So we have our arc length, 55 pi over 18 units. So this is it. This is how you are going to look for the arc length or the linear measure given your angle measure and so with the radius. So once again, this is your teacher Jenny saying good luck to every challenges in life, and please do not forget to like and subscribe and share this video.